started working Terraform the Terraform. Basically, we installed Terraform and also we installed Docker and we ran a small Terraform script, basically which downloaded the image called Node-RED. It's a this tool. We use the Terraform script to deploy. That's what we did. It's nothing major, but that's what we did last day.
Right.
We plan to expand on it today.
Right. Okay.
So let's look in our version started. Let me share my screen. Sanjeeva, is it possible for me to share my screen?
Yeah.
It's sound?
You have all the permission.
Okay, right, thanks. So I will share my screen. Okay, hope you guys can see my screen. So, Terraform Docker. The last step that we did. No, this is the last one. No, last one. Okay, this is what we did. So, I think Stefan was also not present. So basically, Stefan, what we did was we installed Terraform and installed Docker, and we deployed this image called Node-RED. This one, Node-RED, and deployed the container using Terraform. So that's what we did. So let's try to continue from there onwards. If you have any questions, Stefan, Chanak, because you are not present, you can read the ask, so we can start without any ambiguity. Okay. Then. So. No, hard drive is damaged, so it takes a bit of time to read and start. So, yeah, that's the problem.
Oh.
Welcome back. In this lesson,
I'm going this bit. Let's recap what we did a little bit. So the Terraform workflow is Terraform init, Terraform plan, Terraform apply, and Terraform destroy. So that's the basic workflow for Terraform. So Terraform init basically downloads all the providers, and Terraform plan basically generates a plan file or a plan. If we give a plan file as an output, we generates a plan file. Otherwise, it gives us a plan which is a visible representation of what it will do when we apply the plan. So that is the Terraform plan. Then we can apply. The apply is when we apply the Terraform changes. It applies the basically do the things that was scheduled to do in the plan. And the Terraform destroy, once we apply Terraform destroy, we basically brings back the state back to the initial state. So that means there are no resources. So Terraform has several blocks. Terraform has Terraform required providers block. That means those are the required providers. Then we have the provider blocks. We can have multiple provider blocks, and also then the resource blocks are there. Resource blocks is basically the resources that we are going to create or destroy. Here in this one, we are going to create a Docker image, download the Docker image, and we are going to keep the image locally. And then the next one is start the container. So we are starting the container in the next step. So that's the basic workflow. Let's start with the video. We'll watch about 2 or 3 videos, then we'll just have a discussion.
Welcome back. In this lesson, we're going to dive a little bit deeper into what we just did with that Terraform plan and Terraform apply. I've already deployed my infrastructure, so let's take a look and see what happens whenever I run another Terraform plan. As you can see, infrastructure is up to date, so there's no changes that are going to be made. As you can also see, it refreshed the state and validated that that image existed, which we can see here with Docker image ls. Right here, that Node-RED image is available. Now, just a reminder, all of these other Lambda images here are default to the Cloud9 environment, and you can ignore those as those have nothing to do with what we're doing. So I'm going to clear my screen here. Let's go ahead and destroy our infrastructure so that we can take another look at the plan options. So Terraform destroy. And I'm going to confirm this destroy. As you can see, it is destroying the resource we created with ID, latest, name, everything else. So we will type yes to confirm that destroy. And it's completed. So I'll clear my screen, Docker image ls, and it's gone. So clear my screen again. Now what I want to do is run another Terraform plan. As you can see, it says it's going to create a new resource, but it also specifies that I did not specify an out parameter. So I'm not saving this plan, which is typically fine, and it's great because when you run the Terraform apply manually, that gives you another plan and a chance to reanalyze that plan and ensure that you are deploying the right resources. Now watch what happens if I utilize a plan file and an apply. So what I'm going to do is do a Terraform plan, out equals, and we'll just name this plan 1. Okay, so as you can see, we now have plan 1. Let's take a look and see what that looks like. Not something you're going to be able to use. So this is an encoded file, not encrypted, but encoded. So if you were storing secrets or variables or something in this plan, it could potentially be used against you. Keep that in mind. And if you are storing these plans, make sure you still store them with encryption. All right, I'm going to clear my screen and I'll close that plan now. So now let's utilize that plan in an apply. Now, as you remember, when you do a Terraform apply, it gives you the plan here and gives you the chance to enter a value whether you confirm or deny this plan, which is provided with a yes or a no. I'm going to type no. Apply canceled. Now in automation, that can be somewhat of a pain. So let's utilize the plan file instead of just applying without it. Terraform apply, and we'll just type plan 1. Okay, as you can see, there was no confirmation dialog. I was able to use the plan immediately, and it's already creating our resources. So this is great for automation, but not something you necessarily want to do if you are running this manually. And the reason, of course, being you do not get that second chance to approve. So if you do plan on applying the plans directly, ensure that you know what you're doing and you are prepared for anything in that plan to be deployed or changed no matter what's in there. So now let's take a look at some of the other options you'll see with Terraform plan, -- help. As you can see, we've already used the out path. You've got no color, which was used in init also. You're going to see that in just about any Terraform command. We can use input variables, which we will cover later in the course. If you use destroy, that will actually simulate a Terraform destroy. You can compact warnings if you need to. Again, that could be something that could be used for automation or for small terminals, things like that. And you've also got the ability to target specific resources, specific state files, things like that. Again, that's something we will be covering throughout the course, but we're not ready to cover it yet. So let's take a look and see what the Terraform plan destroy looks like. Pretty obvious. It just tells you that it's going to destroy those resources. Okay, so now we've looked over most of the options on Terraform plan, and let's take a look at the options for Terraform apply. And what you'll find is the options are pretty much all the same. So anything that you do with a plan, you can do with an apply, such as specifying variables and compacting warnings and all of that. So do keep that in mind. We're not going to cover any of that as we've already spoken to it, but that is something we will be utilizing in the course as we continue. So that's all for this lesson. You can go ahead and mark it complete and come on back to the next one. Welcome back. In this lesson, we're going to actually finally deploy the container that we've downloaded the image for, and we're going to explain how to reference values from other resources. So let's get started. So what we're going to do in this lesson is we are going to deploy a Docker container. Now, as you can see here, the Docker container documentation is pretty straightforward. At least on the example usage. There are a whole lot of opportunities here and options to modify things, but we're going to keep it fairly simple to start. So what we're going to need to do is reference the image, which as you can see here, docker image.ubuntu.latest is how they do it here. We're going to do it, of course, using the name we provided for the Docker image, which is Node-RED image. So let's take a look at how we're going to do that. What we're going to use is we're going to use a reference. And that's within the expressions documentation, which you can see here under configuration expressions. So you can reference just about anything. You've got variables, you've got modules, and of course we're going to cover all of this stuff as we go through the course. I just wanted to make sure I showed you where to access the documentation. So let's head back over to our script. And let's get started. So first up, we need to create a resource for the Docker container. So resource, Docker container, and we'll name this Node-RED container and use our braces to set up our resource block. And the first thing we want to do here is we want to name it. Now in this case, the name is actually more of a logical value. It doesn't matter what you name it. You just need to name it something that can be referenced if you need to. So in this case, we're just going to name it Node-RED. Now the next step is we need to provide the image. Now the image needs to be referenced from the image resource. So we'll type image. And in this case, that means it will be Docker image, which is the resource, .node-red image, which is the name of that resource, as you can see there, .latest. Now, where are we getting this latest from? There are a few ways to find out your possible options, but we're going to start with the docs. So what we need to do is we need to go to Docker image here in the docs, and let's take a look at the attributes reference. And as you can see, latest is the only reference available for the image, and that provides the ID of the image.
Welcome.
So that's going to give a unique representation of this image that we can reference from other resources. So back over to our script, we've got latest there. That's going to reference that image and deploy the container. Since Node-RED needs to be accessible externally, we need to expose some ports. So let's take a look at our Docker container. And I'm just going to do a Control F for port. There we go. Ports. Let's take a look here. See ports below. There we go. That is linked. So I'll click on that. Ports. We have internal, external, IP, and protocol. We're going to be using the internal and external. IP will expose on all listening IP addresses on this instance, and protocol is going to default to TCP, which is what we're using. So let's go ahead and set up these internal and external ports. So what we'll do is we'll type in ports, and this itself is a map. So we need to include another set of braces as this is a separate block. So we'll do internal equals. Now the internal port for Node-RED is port 1880, and we'll actually do that as a number. Terraform calls this a number, not an integer. Keep that in mind. That will come in handy later. Then we're going to do external, and we'll just map that also to 1880. Now, generally speaking, unless you change the Docker file, the internal port will always be 1880, but the external can be different. We can expose this port on different ports on the server if we'd like. But in this case, we'll just keep it as 1880. So all of that's done. I'm going to save my script. I'm going to run Terraform format. Okay, and as you can see, it just kind of cleaned up my spaces there. I could probably go in and change my spaces to 2 spaces instead of 4 and not have to do that. But Terraform format makes it easy, so I'm not going to bother right now. Clear my screen. So once I've done that, let's do a Docker PS. Nothing's run yet, so I'm going to clear that. Now let's do a Terraform plan. Okay, as you can see, we have one thing to add, and that is the Node-RED container. As you can see, we have a lot of options here, many of which are known after the apply. These are all attributes that you can query in the future, which of course we will do in a later lesson. Here is that image that we referenced here. As you can see, very unique. And then here are our ports. As you can see, IP defaulted to 0000, and the protocol defaulted to TCP. Everything looks good, so let's go ahead and run this apply. Clear the screen, Terraform, apply. And everything looks the same, so I'll type in yes. And we'll give this a few seconds. There it goes, it has deployed. And as you can see, we now have a terraform.tfstate file and a tfstate.backup file indicating that the state was changed. So I'm going to clear my screen. And now let's do another Docker PS. As you can see, there's our container. All right, so that's all for this lesson. Come on back to the next and we will continue the course. Welcome back. And in this lesson, we're finally take a look at that container we've deployed and access the Node-RED.
No, Sanju, yeah, please go ahead, Sanju.
In that last video, Masanka, I didn't capture that. In that case, he changed the resources alias name, also changed the Docker image. Why is that?
This one, right? Hello.
Yeah, that's one. That's one.
Yes. So here, This is the first resource.
Okay.
So we are giving an alias called NC. I have given an alias called NC rate.
Yeah.
So that is referred here. Docker underscore image, this one, and NC rate latest.
So that means that image doesn't in the already occur in our image repository.
No, we downloaded from Docker Hub.
That is it is a reason for the we can no. I asked the question that if we create Terraform script first time, we can use this way. Can we use this way?
Yes, so you download the Docker image and then run the container. No, the question is not clear to me. That's the issue.
No, that in that last session, that earlier we create the Docker resources. The resources is Docker container and alias mean NC container.
Yes.
Each that in the inside of that image was a Docker image dot latest. That Docker image is he changed last video. He changed that.
Change that means no, I don't understand.
That image. He changed the image to some another NC rate Docker image. Can you please repeat that video?
Okay, sure. Let me share the screen again. Yes, sorry, go to the video again.
Welcome back. In this lesson, we're going to actually, finally, deploy the container that we've downloaded the image for, and we're going to explain how to reference values from other resources. So let's get started. So what we're going to do in this lesson is we are going to deploy
directly that.
Sorry?
We can directly go to that Terraform script.
Docker that's within the red container. The image here. So what we'll do is we'll type in ports, and this itself is a map. So we need
Docker image changed. You can see.
What is has changed?
Line 18.
Sorry?
Line 18.
18. That is because if you take my script, this is the Docker image.
Right.
And NC.
That's the image we use inside of the image tag. All right.
Yes.
Okay. Now we can continue next time.
Okay.
Welcome back. And in this lesson, we're finally going to take a look at that container we've deployed and access the Node-RED application that's hosted within it. So as you remember, we deployed Node-RED. As you can see, Node-RED is running, and it's running on port 1880. So what we need to do is we need to access the EC2 compute instance that's running Cloud 9 on port 1880. Now, if you haven't whitelisted your IP address already, as indicated by the Cloud 9 setup video, please go back and complete that. Ensure you have all access, or at least access, on TCP port 1880 to this instance. So just to let you know, we will be using other ports in future lessons, so ensure that you've allowed more than just 1880, or at least you are prepared to do so. So what we want to do first is we want to obtain the IP address of this instance. Now you can absolutely go straight to the EC2 console and access that, but we're going to do it the fun way. We're going to use the AWS Instance Metadata Service to find that IP. Now, of course, this is not an AWS course. This is a Terraform course, so we're not going to dive deep into how this works, but feel free to check out the AWS documentation to do more research. So I'm going to do a curl HTTP 169.254.169.254 latest meta-data /public-IPv4. And there we have it. So that is the IP address of this instance. So I'll go ahead and copy it, open a new tab, paste it in, and access port 1880 on that IP address. And there we are. We are now in Node-RED. As you can see, we've got a little warning here. We will address that later. Do know right now, you feel free to play around as much as you want in this, but whenever you destroy this container, you will lose everything you've done because there is no volume attached. We will deploy that volume on a later lesson, but if you'd like to go ahead and research the documentation and do it yourself, by all means, feel free to do so just so you can play around with Node-RED. Now, just an example of how Node-RED works, we will drag this inject out, debug. Obviously, none of this will be on the exam, but Node-RED is a pretty great piece of software. I'm going to set the message payload to a string, hello world, done, deploy. Click go, and we've got our hello world. So congratulations, we've got Node-RED all deployed. Everything is good to go. So come on back to the next lesson as we continue.
So I have the same script with me. So let's try to deploy this and see the same method I have also used. Let's start deploy this and see what situation. Previously I have deployed, but let's try again. This time again and we will research the final present. Terraform. I think this will not do any changes. It says already successfully initiated because I have done it previously. Terraform. So these are the changes that it will do. It's saying I have done some changes outside of Terraform. So that's a bit of a complication. I may have stopped the containers, but let's see. What we can do. I'm also not an experience in this, but let's see what we can do. So it says let's apply let's see whether it will give any error. I may have stopped the containers manually, so that might be the reason that hasn't. Let's see what the is. Yeah, container is still starting, so even though the message came as we have done some changes outside of Terraform, it seems to work okay. Apply went through. Let's wait till the container is healthy. Still starting. Now it's helping. Now I will go to the browser and let's fill the Terraform output, output of Node. Yeah, so it's loading. Okay. So this is what the initial, this is where we stopped actually last day. Let's continue from that. If you have any questions, please ask. I will try to explain to the best of my knowledge.
Sangha, sometimes your sound is breaking.
Yeah, that's because, sorry about it, that's because there is, in front of my house, the battlefield, there is a tractor that's
Uh,
like
no, no,
operating
no,
battlefield.
we can understand.
Yeah, then it's, hopefully it's okay. Very close to my house, that's right. Okay. So let's go to the next video.
Yeah, we
This is the very important concept now. The next coming Terraform state. So as you can see here, you can see when I type LL, you can see Terraform TF state file has been created. TF state backup has also been created. So it's very crucial to understand this concept of Terraform state and the function of TF state file. So one of the major concepts in Terraform. So better to listen carefully as much as possible and try to understand what is function of the TF state or the state file and how we can work with it. Please listen carefully. Syntax, sometimes syntax, even if you don't remember the syntax, it's fine because you can find it online, the syntax. But the concept of TF state file and how it works is very important.
Welcome back. And in this lesson, we're going to dive a little bit deeper into our state that was created after our Terraform apply. Now, Terraform state is basically the description of all of your resources that you have deployed. So let's take a quick look at the Terraform state that was applied on our last apply. Okay, so here's our state here. As you can see, we've got a version, Terraform version, and then here we've got the serial and the lineage. Now the serial is updated every time a resource is updated within the state, or really anything within the state. So whichever state has a higher serial, if for some reason you have multiple states, that state is the one that's going to be considered when running Terraform operations. Now the lineage is created when the state file is created originally. So it's a way to determine whether your state file is the correct state file that was created when your deployment was initially created. So if that lineage is different than what it's supposed to be, Terraform is not going to allow this. Now this comes into play more when you're dealing with remote backends, which is something we're going to dive into a little bit later in the course. And as you can see everything you've deployed and all of its metadata. You've got your IP address of the Docker container. Networking mode, you've got the external internal ports as you remember that we created. Here you've got the dependency listed. Docker image, Node-RED image. Obviously the container needs to have access to that image because that's the image that the Docker container was deployed from. And since this is a dependency, that means that Terraform knows the order in which it needs to apply or destroy resources. Then as you can see, there's a lot of other information here. Some of it will become very useful in future lessons. And all of that can be found in your terraform.tf state file. Now you may or may not have the TF state backup file yet. That's something that is here since I've run this a few times before, not just once. But what I'm going to do now is I'm going to destroy everything that's here. So I'm going to do a Terraform destroy auto approve. Now again, You generally don't want to do this, but since there's nothing here that really matters, we're going to do it. You usually want to leave that off so that you can have one last chance to cancel the destroy if you notice something's wrong. So I'm going to destroy that. As you can see, modified my state right in front of me. Deleted all of my resources right there. So I'm going to clear this screen. So now let's take a look at the TF state backup. TF state backup is now the last state that we had. So everything here is the previous state. So if we need to reference something from the previous state, we have access to it in this backup file. So now let's take a look at how things are deployed one more time. I'm actually going to delete the TF state and TF state.backup files. Let me bring this back up here, and I'm going to do another Terraform apply. And once again, I'm going to do auto approve. So as you can see here, a state file has been created. And there's nothing there, of course, yet because nothing's been created. Give that a few seconds to get going. And it automatically in Cloud 9 pops up and asks me to refresh that file. If you're not using Cloud 9, you may need to do that another way. And there we are. So now we have our state. So if I perform a Terraform destroy once again, that once again creates a new state file. It creates the state backup file, which you can see has our previous state in it. All right, so now let's take a look at other ways to get information from our state. You generally want to avoid accessing these state files at all costs. In fact, they should be encrypted if possible because they can contain very sensitive information, such as the IP addresses that provide access to your instances, passwords, variables, things like that. State is not encrypted by default. Now, depending on the backend you use, it may be encrypted automatically, it may not be. You can store it in areas such as S3, you can use HashiCorp's cloud product, and there are several other options in which you can store state. But we'll cover that as we go through the course. So one thing I want to do, since we're going to be dealing with JSON here, I'm going to maximize this screen. We're not going to be using those folders anymore right now or the files above. So let's go ahead and install an application called JQ. Now I already have it installed, but this is the command you're going to use, sudo apt install JQ, just like so. And this will allow us to view our state easier within the CLI. So what I'm going to do is use the Terraform show command -JSON, and then I'm going to pipe that to JQ, just like so. So as you can see, there's nothing going on in that state. So we go Terraform apply, auto approve, and we'll wait on that one more time. All done. Let's do Terraform show -JSON pipe JQ. And there we are. So now we can see all of the information in our state without accessing the file directly. But remember, anyone who has access to this console has access to all of your state data. So make sure if you have any type of secrets, you are managing those properly. And again, we will cover that more as we continue through the course. Now, one more thing I want to show you for accessing our state information, you can use Terraform state list. Now what that does is that shows us all of the resources within our state. So this is a great way if you're troubleshooting for variables or references or trying to find ways to output different information. Being able to hop in and just look at the resources that you've got deployed is very useful at times. So between Terraform state list and Terraform show, you can access most everything you need within your state. All right, so we're going to stop here. Come on back for the next lesson and we'll continue the course. Hello and welcome back. In this lesson, we're going to cover an easier way to display important metadata about our deployment without having to dig through the state for commonly used attributes. These are appropriately named outputs. Outputs allow us to export and modify state information from our deployment to be displayed on our terminal, consumed by other applications, or by Terraform modules, which we'll discuss later in the course. So let's get started. So first, if you haven't applied, go ahead and do that. Now we are continuing from the last lesson where we left off. So I'm going to go ahead and do a Terraform apply and auto approve. Give that a few seconds. Okay, so now that's done. I'm going to go ahead and maximize my terminal here. We don't need the rest right now. I'm going to do a clear. And the first thing I'm going to do is take a look at my current state. Now obviously I could open the file, but it's better to use the Terraform commands as they were intended. So I'm going to use a Terraform show. Okay, so as you can see here, we have our state and all of the metadata. We have our gateway, hostname, ID, image, IP address, all of this information for the container that we've deployed. So I'm going to go ahead and clear the screen. Now, what if we want to parse through that data? There are, of course, a lot of ways to do that. One way is just to use grep on a Terraform show. Let's look for the IP address, for instance. Okay, there we are. So now we can see those types of values. Perhaps if we want the name, we can do a grep name. We've got a name and a host name there. And of course, the image name also. Let's go ahead and clear that. Now, what if we want to export those values from our script? Let's go ahead and take a look at the resources we've deployed, like so. Okay, as you can see, we've got our Node-RED container and our Node-RED image. So what if, for instance, we want to access the name of that Node-RED container? Now, as you remember, as I did before, Terraform show grep name. You can see that it just goes by name. That's the attribute that we want. So if we use the Terraform console, which is a new tool we haven't used, go ahead and type in Terraform console. You can access all of the attributes of state right from here. It's just a CLI tool that's provided with Terraform. So if I were to do docker container dot node-red container dot name, as you can see, that outputs Node-RED. Now what if I wanted the IP? I could type in docker container dot node-red container dot IP underscore address. And there we are. And that, of course, is the IP address of the container locally. That's not the external address that we need, which we accessed using the AWS metadata service earlier. But this IP address is useful from within our EC2 instance. It's just not useful externally. But let's say we want this information to be output from our script. So I'm going to use Control-C to leave the Terraform console, clear my screen. Then I'm going to click this here to get our script back. And what we want to do is we want to use an output value. Now within the docs, as you can see, docs configuration outputs.html, I'll display that link, of course, larger and provide it within the course. You can see how to display that. Do an output, a value, and a description. So let's go ahead and do that for those two pieces of data we want to output. So I'll head back to my script. I'm going to drop this a little bit here. Let's go ahead and add output IP address, just like so. Then we'll open a brace, and of course that is matched with the closing brace. Underscore container dot node-red container. Display that link, of course, larger and provide it within the course. You can see how to display that. Do an output, a value, and a description. So let's go ahead and do that for those two pieces of data we want to output. So I'll head back to my script. I'm going to drop this a little bit here. Let's go ahead and add output IP address, just like so. Then we'll open a brace, and of course that is matched with a closing brace. Let's go ahead and type value equals docker underscore container dot node red container dot IP underscore address. And again, we're referencing that resource here, docker container dot node red container. And then we're just accessing an attribute IP address afterwards. And that attribute we obtained by utilizing Terraform show. So after that, let's add a description. Description equals the IP address of the container. Okay, I'm going to do a Control S to save. Now let's take a look at a Terraform apply and see what it provides. Clear my screen again. Terraform apply, auto approve. Oops, okay, so here's an error that I wanted to point out. And this is somewhat of a newer syntax requirement. The outputs cannot contain spaces. So I'm going to add a dash here and save that. And then let's try to apply again. I'll press up a couple times to get back to my command and hit enter. Okay, as you can see, now it works. And again, that space requirement is new. Now you cannot have spaces and you can't have any type of special characters other than, as the error indicated, letters, underscores, digits, or dashes. So do keep that in mind whenever you're building out your outputs. You are not able to use spaces within the outputs like you used to be able to. All right, so now that's done. Let's go ahead and output the name of the container also. So we'll go ahead and type output container-name value equals docker container dot node red container once again dot name. Then we'll add a description to keep things well documented. The name of the container. Control S, and now I will do a Terraform apply once again. And there we are. Now we have the container name equals node red, just like so. So I'll go ahead and clear my screen. Now there's one other way to view the outputs, and that's to go ahead and just type Terraform output, just like so. So you don't have to apply every time that you do this. All you need to do is type Terraform output, and that will provide the output. But of course, if you have not applied yet, these outputs will not exist until the state file is populated. All right, so that's all for this lesson. Come on back to the next one as we continue the course.
Hello. Hello.
Hello, Masan.
Yes. I have modified the script. This is what I did. The same way that tutorial author did. So my container name is alias is MC container. So I have defined two outputs. One is container underscore IP, other one is container underscore name. The value for the first one is docker underscore container, that is coming from here, and NC container is coming from here, and the IP address. And the container name, docker underscore container, NC container dot name. Let's try to
we need to destroy it first?
Look like that. So let's destroy and see. I also think that's the way it should be. Yeah, so it gives the name and the container ID as the output. So it's a good coding practice to have these outputs to see what is happening. So I'm also a bit confused regarding how to do this apply, destroy, and how to like do it properly. But let's see. Shall we continue further?
That in this case that if we change the Terraform script middle of that Terraform script after first deploy the Terraform script, if we change the Terraform script middle of the our session, so do we need to destroy and recreate that one? No, we need to apply.
Yeah, that's a bit confusing for me as well. But let's see. Let's apply this. Let's see how it works. Terraform apply.
Should it work?
No, it's now don't need to apply. Let's destroy Terraform. Destroy this. I don't know how to comment this Terraform. So let's check that online. I'll check it online. Sorry. How to comment? Start with a hash. Slash star star. Okay, so let's go to main.ca and let's comment this out. Yes, let's continue. Now Terraform, the Terraform now is destroyed. So Terraform apply. Now it's only showing the container IP. It doesn't show container name. Now let's modify the script again, uncomment it. Okay, then now again we should apply. Don't need to destroy, I think. Yeah, it's showing the IP and the both name as well.
It's working.
So we don't need to destroy it. We can just apply. We will apply on top of what it is already existing.
Okay.
That was a good question. I also had the same confusion. I was a bit difficult for me to figure out what the problem is. So we can. Shall we move forward?
Yeah, we move forward.
Welcome back. In this lesson, we're going to learn how to create an even more useful output by introducing Terraform functions, more specifically, the join function. Terraform functions are very similar to most programming languages as they have a function name followed by a parentheses containing arguments. So let's take a look at the join function in the docs. As you can see, like many higher level programming languages, the join function has a separator and a list. As you can see, join, got your separator here, the comma, and then a list following that comes together to produce these comma separated values. So let's head back over to our Terraform console. Go ahead and type Terraform console, and let's try some of our own. So first, let's just do join, parentheses, and let's do a semicolon delineated list. We'll just type thing 1. Now, as you can see, thing is a string, so that's got the double quotes around it. And 1 is an integer, so that's left alone. Let's close our parentheses there and hit enter. As you can see, we've got thing 1. Now, if I press up, add a space there, that space is considered because it's within the quotations just like any other string. So now let's take another look at a slightly longer one. I'll do join, parentheses, dash, like so. And of course that's in quotes. And let's just say this sentence has 2 plus 2 dashes. Enter. As you can see, this sentence has 4 dashes, so it does perform arithmetic. That is one thing Terraform console is able to do. It will perform arithmetic, just like so. Okay, so enough of the boring foobar baz type stuff. Let's go and do something actually useful. So what if I want to produce, instead of just the IP address, what if I want to produce the IP address of the container and the external port on which Node-RED is exposed? Let's go ahead and take a look at that. I'm just going to open my TF state here, and let's go and find that external port. Scroll down, there we go. We've got internal and external, and then we've got our ports here. So as you can see, ports has multiple values potentially. You could potentially have 2 of these arrays, or 3 or 4, however many ports are provided for this Docker container. So let's see if we can access this from within the console. So first what we need to do is let's go ahead and access Docker container.node-red_container.ports. We'll start there. Okay, as you can see, that provides lots of ports, but we just want the external. So I'm going to press up to add that again, and let's just type in external real quick. And as you'll see, there's an error. So since this is expecting potentially multiple values, we need to add the index for this value here. And that index, of course, is 0. Just like a good programming language, HashiCorp configuration language starts their indexes with 0. So back in our console, I will press up again. I'm going to scroll back here and add 0 and hit enter. And there we are. So now we have the port we need, but we need to add that to the IP address. So we've already found that here. Let's go ahead and type that in. Docker container.node-red-container.ip address. As you can see, that's there. So now we need that, and we want a colon in between it because that's how you access an IP address and a port. We'll add a colon and then the port. So what we need to do is use the join function for this. So what we'll do is do join, use our quotes and our colon, comma, and we'll go ahead and type in those 2 references. So we'll start with Docker container.node-red-container.ip address, and then we'll use a comma. And notice I'm not using any quotes here because this is a reference. And then we'll type in Docker_container.node-red_container once again, .ports 0.external. We'll close that bracket and that parentheses and hit enter. Perfect. We have just what we need. You could even add an HTTP to this, of course, if you wanted to. You can add whatever you need to, but right now I think this will suffice for our needs. So let's go ahead and add that to our IP address output. So I'm going to change the description to reflect that, the IP address and external port of the container. And I'm just going to highlight this since we've already done it and copy it. So here, I'll go ahead and clear out this value, paste this in like so, and hit Control S to save. All right, so down here, I'm going to hit Control C to get out of my console and clear the screen. So now let's run Terraform output. As you can see, that's not referenced yet because this does need to get applied. So I'll hit Terraform apply. -- auto approve, just like so, all set. Clear my screen, and let's type in Terraform output again just to see it. Even though it was output on the apply, I just wanted to see it here. IP address 172.17.0.2:1880, just like we're looking for. All right, so that is an introduction to the join function. As you can see, there are several more functions here. Feel free to bounce around through those and peruse those. But we will be revisiting several of these functions throughout the course. All right, so that's it for this lesson. Come on back to the next one and we will continue.
Hello, Sanjeev.
Hello.
Yeah, do we need to continue?
Yeah, I also couldn't like write it, write the syntax from one look at it. It's with long syntax now. I will first share the Terraform functions link, so you can bookmark it or keep it with you. And also, I will also bookmark that. Let's Sanjeev Chanak is there. So did you like understand the concept, right?
Yeah, I do.
Okay, right. Thanks. Then this great. Let's try to do it. I will share the screen. So this is Terraform console. Okay, and let's. I will take the video to my side and let's try to come up with the
Comma, and we'll go ahead and type in those two references.
join. We have put this what we want to join inside the curly brace. Sorry, inside the brace. Then the list. Okay, thing one on thing. Put the other way around. Yeah. Then the other one needed was join. This contains this This is what he did the second time. So here the first one in the first point is getting replicated between the four, right? Okay. Then the next one was the port thing. That was the bit complex one. So this is the underscore container. My container name is NC container. NC. Yeah, container. NC container. I haven't applied this. So we have to control C and we need to apply.
Ah,
I haven't done the apply. I have destroyed. There are okay. Terraform. So docker underscore container nc container um, oh, okay, we are getting this data structure to list.
so
Data
in
structure.
that Terraform console, it doesn't have any intelligence.
Sorry.
We didn't have any intelligence. That means that dot after the dot, you can't predict the next sentence. Right? We have to manually type all the commands, I think.
Yes. So this is how to get the port exactly. Exact port. So now we need to port is an array to list. List is array list. It's a list. So the first one is the external board. Port. So now join the syntax now we need to join syntax is join underscore container C container container IP underscore admin. Yes, comma docker underscore container container right. See in here container හරි නේද?
sorry මම mic off කරන් කතා.
හරි. මේ හරිනේ. fully qualified IP එක වෙන්න ඕනේ.
ඒක ටෙස්ට් කන්ටෙන්ට් එකකට තමයි අතරම ඒක මේ අදාළ වෙන්නේ.
ඒ කියන්නේ
දැන් ඒ කමාන්ඩ් සෙට් එක අපිට අදාළ වෙන්නේ. එහෙමද නැත්නම් ඒක Terraform ඕන එකකට use කරන්න පුළුවන්.
පුළුවන් ඕන එකට use කරන්න පුළුවන්. මේක දැන් මේ ෆන්ක්ෂන් ගොඩාක් තියෙනවා. ඔයාලට මම ඒ link එක ඔයාලා බලුවද?
ඔව් ඒක තමයි.
ෆන්ක්ෂන් ඔබයක් තියෙනවා join lower regate replace split strv string title string breaks string suffix string space upper lower ගොඩාක් තියෙනවා functions.
මේවා මොකක් හරි අවශ්‍ය දෙයකට ඒ default දාලා ගන්න ඕන මේ වගේ numeric function string collection ඒ වගේ ඔක්කොම තියෙනවා කියන එක තමයි අපි දැනගන්න. මොකක් හරි එකකට අපිට ඕන කරන එක මෙතනින් තෝරගන්න ඕන.
ඔව්.
මේක පොඩ්ඩක් මේ function ටික පොඩ්ඩක් testing කරා හරියට. අපි ඊළඟට යනවද නැත්නම් ඊළඟට ගිහිල්ලා නතර කරන්න?
ඔව්.
අසංග මේ තව එකක් දැන් මේ අපි දැන් අර එක ඉමේජ් එකකින් ඩවුන් මේ කරේ. එතකොට දැන් ඩොකර් හබ් එකේ තියෙන ඕන ඉමේජ් එක ගන්න අපිට මේ සෙටප් කරගන්න ඔක්කොම කරන්න කම්ප්ලීට් කරන්න පුළුවන් මේකද දාගෙන.
ඔව් පුළුවන්.
ඒකට අපි දැන් ඔය ඕක වගේම වෙන අපිට නිකන් සූටබල් ඉමේජ් එකක් තියෙනවද? MySQL හරි
මම පුළුවන් ඉන්ජින් එක ඕන එකක් පුළුවන්.
ඉන්ජින් එක්ස් එක දාගත්තා නම් හරිනේ කම්ප්ලීට් කරලා බලන්න නිකන්.
ඔව් පුළුවන්.
මගේ EM එකේ තාම මට මේ නෙට්වර්ක් හදාගන්න බැරි වුණා මේ. තමයි එකම.
එහෙනම් ඊළඟ වීඩියෝ එකට යමුද?
ඒකට යන්නේ.
Hello and welcome back. In this lesson, we're going to discuss what you might think sounds a little like a fairly random resource, but it is incredibly important. That resource is the random string resource. One of the major tenets of Terraform is idempotence and the ability to scale up and scale down resources without conflicts, especially with something as simple as naming. By using random strings, you can ensure the names of your resources or other attributes will not clash and cause issues with your deployment. So let's get started. Alright, so let's start with the problem we're facing. First, what I'm going to do is go ahead and apply my infrastructure. So I'm going to run a Terraform apply. Now, if you've already run this, of course, you can go ahead and skip and let it create. This will take a few seconds as usual. Okay, all set. And as you can see, we've got our container deployed. There's its IP address from the outputs we set up. So everything's deployed. Now, what if we want 2 containers? There are a few issues that you might encounter that could cause conflicts. You've got the resource name, you've got the name itself of the container, and then you've got the port. Well, I'll go ahead and make it easy, at least for the port. By commenting that out, Docker will automatically choose a port for you. So you don't need to worry about that. So go ahead and comment that out, and then on your own, go ahead and create a second one of these resources. So go ahead and copy paste that one and make the necessary modifications to deploy 2 of these containers. Once you're done, come on back and we'll continue. Alright, how'd you do? Did you get it to deploy? Hopefully you did. But if you didn't, here's how to go ahead and get that going. We need to make sure that the resource name is different. So I'll just add a 2 to the end of that. And we need to make sure the name is different. So we'll add a 2 to that. Not a whole lot of work. Go ahead and save that, and let's run an apply and see what happens. Okay, great. So we have 1 added and 1 changed. Obviously, our outputs didn't change because we're only looking at that 1 resource. So, although this worked, what happens if we want 5, 10, 15, 20 resources? Obviously, just saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. and so on is not the ideal solution for this. Also, once we start using count, you'll see the sky's the limit on the number of resources you can deploy. So we need to ensure that these always have a random name because you're not always going to be able to just assign a random number here unless you want entire pages and pages and pages and massive files full of duplicated resources, which is not the way Terraform was meant to be used. So let's go ahead. I'm going to clear my screen. Then what I'm going to do is just do a Terraform destroy, auto approve, just to clean things up. Clear my screen. And now what I want to do is just go ahead and configure these to have a random suffix. So the name will look like something like ABCD or 1, 2, 3, 4 or something like that. So that way it always comes up different. Let's head over to the docs and take a look. So within the docs, you have random ID, integer, password, even pet if you want to name your things after snakes and spiders and dogs and stuff. We've got shuffle, string, and UUID. We're going to use string. It's a little more customizable and still, as you can see, uses a cryptographic random number generator. If avoiding collisions is important, make sure that it does use a cryptographic random number generator. Of course, the UUID will, password, integer ID, most of them do. All right, so let's go ahead and create our random string. Now, this is a totally new resource, so we're going to use that. And what we've got random string. You need to name it just like any resource. And then we've got some special attributes such as length, upper, min upper, lower, min lower, number, etc. So what we're going to do is set the length to 4. We're not going to use special characters, and we're not going to use uppercase letters. So I'm going to head back over here, set up my resource, random string, and we're just going to name that random, just like in the docs. Then what I'll do is open and close my braces there, and we're going to add the attribute length equals 4, special equals false, and upper equals false. And I will save my file. Let's perform a Terraform init since we added another resource. So now let's run another Terraform apply and see what we get. Okay, as you can see, the random string was created for CKW right there. So that's good. Okay, let me clear my screen and let's go ahead and type in number, etc. So what we're going to do is set the length to 4. We're not going to use special characters, and we're not going to use uppercase letters. So I'm going to head back over here, set up my resource, random string, and we're just going to name that random, just like in the docs. Then what I'll do is open and close my braces there, and we're going to add the attribute length equals 4, special equals false, and upper equals false. And I will save my file. Let's perform a Terraform init since we added another resource. So now let's run another Terraform apply and see what we get. Okay, as you can see, the random string was created for CKW right there. So that's good. Okay, let me clear my screen. And let's go ahead and type in Terraform state list. There we are. As you can see, we have our random string.random. So that resource is done. Let's go see what type of attributes we can access for that. Obviously, we can look at the docs. And we can see that result is the only attribute that you can access. Just a point of clarification, I called these attributes earlier. These are arguments. Both start with A, so I apologize for that. So, as you can see, we've got a result. Now you can also go into Terraform show, and you can look here and see the result is right here. Now you can also access it via ID, but Terraform's docs recommend using result. So that's what we're going to use. So I'm going to clear my screen here. And now what we need to do is use that join function that we used before to add that to the suffix of our name. So we're going to do that. Go ahead and just do it for name. Don't bother doing it for the resource. We're just going to leave those the way it is for now. So go ahead and use join. And I'll use a hyphen there. And we will start it with Node-RED. And then we'll add random string.random.result to the end of that. Just like so. So now that we've done that, let's go ahead and apply and see what happens. Okay, as you can see, the container name is Node-RED-4CKW. So now if you were to create a second random string and apply that to the second resource, you'll be able to ensure that these container names never clash. So go ahead and do that. Go ahead and create a second random string resource, modify the second container resource to utilize that, and then as an added bonus, go ahead and create outputs for both of those resources. And just a little hint, remember that the other outputs are going to have to reference Node-RED container 2 and not Node-RED container 1. So go ahead and do that and come on back when you're done, and let's see if everything looks right. Okay, how'd you do? So as you can see, I have created the second random string resource, random2. I have joined and accessed that random2 result here to our Node-RED container. And I've created the 2 second outputs, each one referencing the second container. So I'm going to clear my screen and go ahead and do another Terraform apply. And let's make sure it works. All right, perfect. And as you see, I've also cleaned up this output name and got rid of the capitalizations just to make sure that everything is consistent. So once again, I've just renamed the resources here to match the ones I've created. And everything works out and we have no collisions. So that's it for this relatively long lesson. Come on back to the next one where we will start looking into the count feature of Terraform and get rid of all of this extra code.
Hello, Sanjeev.
Hello.
ඔව් ඒක ප්‍රැක්ටිකලි කරලා බලන්න ඕනේ
ඔව් කළා බලන්න අපි ඒක හෙට බලමු නේද?
කවන්නේ මේ මම
කවන්නේ.
මේ
කවදන්න.
YouTube එකට දාලා තියෙනවා අපිට මේ ස්ටෙෆාන් මම group එකට දාන්න link එක. ඒතකොට අපිට
මම දැක්ක.
බලන්න පුළුවන්.
ඔව්.
අද දැන් මේකක් දාන්න. ඒතකොට අපිට මේ බලලා කරන්න පුළුවන්.
ඒක හොඳයි.
අපි හෙටද වඩන් ගන්නෙ. හෙට කරන්නේ. මේක පොඩ්ඩක් ප්‍රැක්ටිකල් කරන්න ඕන වස්සන්.
ඔව් ප්‍රැක්ටිකල් කරන්න.
ඔයතර පොඩි ප්‍රැක්ටිස් එකක් තියෙනවානේ.
ඔව්.
මේ අනිත් වීඩියෝ එකක් දාන්න එහෙනම් අපි අපිට අවසර ටෙස්ට් එකක් කරලා අපි හෙට කීයටද හෙට 10ට මීට් ඕනේ.
ඔව් 10ට විතර බලමු.
මේ ලින්ක් එකම ජොයින් වුණා අපි මීටින් හදන්න ඕනේ.
හරි හරි.
නැත්නම්
අද සංජීව එනවා පොඩ්ඩකට තියන්නද?
හරි හරි.
Okay, bye.